Assalamualaikum warahmatullahi wabarakatuh to our beloved lecturer, Sir Nazri. So today, me and my friends are going to present our lab report. The topic for our lab report is about the simple pendulum. My name is Rabiatul Adaba binti Muhammad Zamri as the first presenter. My metric number is 2020, 60, 41 and 48.
Assalamualaikum warahmatullahi wabarakatuh. My name is Noor Alia Batrisha binti Kar Azhari. I'm from AS 12028.
Mardia binti Mustaqim and my matrix number is 2020-892-588 from group AS12028A.
Today I will talk about the objective first, the objective of the experiment, and followed by the theory and lastly the result. The objective of this experiment is to find the value of g acceleration due to gravity.
So for the method of the experiment is number 1, an eraser being tied to 0.1 meter thread to use as a pendulum. Number 2, the pendulum being measured at 10 degrees before launch. And number 3, time being taken after 10 full oscillation by stopwatch. Number 4, mass, amplitude, length, period of pendulum being recorded in data table 1. Number 5, step 1 until 4 being repeated using a different length of thread until 1 meter. Apparatus and materials of this experiment is stopwatch, thread, eraser, and also protector. So you can see in diagram 1.1, here this is how we do the experiment.
Okay, next the theory. Theoretically, a simple pendulum is defined as an object that have a small mass. So in this experiment, we use an eraser as the pendulum. The pendulum is suspended using a thread or string so that it can swing freely back and forth under the influence of gravity. A simple pendulum consists of mass, which is the eraser, and length of the thread, which 1 meter thread. Here I attach the formula that will be used to find the value of gravity below. So the formula is T equal to 2 pi multiplied by square root of L divided by G. T is the time required for the swing to complete the oscillation once. L is the length of the thread or string, and the last one is G, stand for the acceleration due to gravity. The actual value of G is 9.81 meter per second squared. By running the experiment, we will know the value of G that we calculate using the formula above is same as the actual value of G or vice versa. Okay, next we have result. So this is our result. Since there are 3 members in a group, so we have 3 time readings. Other than that, we also have average of time. We get it by plus T1 with T2 and T3. After that, we divide by 3 because we have 3 time readings. Apart from that, we also have the period. We calculate the period by dividing the average of time with 10. Why we divide by 10? Because period is for only one oscillation. So since we run this experiment for 10 oscillation, that is why we divide by 10 to get the period for one oscillation only. So that's it for my part. We will continue with my friend.
So for analysis data that we have to make from the graph paper. So here we have to plot all the data here, and this is the period 2, and this is length. So from here we have to take 2 points. I put this one and this one, and then we have to make a triangle to find a gradient here. So to find a g, first we have this equation, m equals to 4 theta powers of 2 equal divided by g, which is gravity. So first we have to find m, which is y2 minus y1 divided by x1 minus x2. So we get the m, which is the gradient, which 4 minus 2 divided by 1 minus 0 0.5 we get from the graph. And then we get m equals to 4. So now we just replace m in the equation, and then we get the g. G equals to 9.86 meter per second.
So next, I will take over for the discussion and the conclusion part for the experiment. So for the discussion, based on the graph, the time taken for the pendulum to make 10 complete swings increases when the length of the thread is increases. While doing the experiment, the angular displacement of the thread was fixed at 10 degrees by using a protector, and the same type of eraser was used to make the pendulum or the weight for the pendulum. So the type of eraser that we use in this experiment is a Faber-Castell eraser with same size and same weight. And the relationship for the graph L versus T squared is directly proportional with L. So we can see it from this graph. The time squared increases when the length also increases. So the relationship is directly proportional because the line graph touches the origin part here, which is the 0, 0 coordinate. So next, the gravitational acceleration calculated or we obtained from this experiment is 9.86 meter per second squared. But based on the theory, it should be 9.81 meter per second squared, which accounted or with difference for 0.05 meter per second squared. So there is a difference value from what we calculated and from the theory, because it happens due to uncertainties, because there are few errors happen due to environmental conditions and the observer error. So examples of errors due to environment is because of the wind, and for the observer error caused by the parallax error. So to reduce the errors, the experiment should be done in a non-exposed or in a covered areas, such as a room. So to get more accurate reading, the fan in the room should be turned off and the windows must be closed. So to fix the parallax error, we should make sure that that our eyes or the observer's eye are perpendicular with the scale of the protector when taking readings for angular displacement of the pendulum. So next, the conclusion for the experiment. The accepted relative difference value should not be more or less than 20% from 9.81 meter per second squared, which is the theory value. But in this experiment, value of g or the gravitational acceleration that we get is 9.86 meter per second squared, which is an accepted relative difference value, because the relative difference is only just over or more with 0.51% only. So the difference is not more or less than 20%. So the experiment also can be done one more time by using 5 oscillations or 5 degree for the angular displacement to get more precise value. So the hypothesis is accepted. So I think that's it from our group. Thank you.